Welcome back. In this video, we're going to finish up our manufacturing application of linear programming, where we're given a company that produces three different types of widgets. We came up with an optimization equation giving the certain amount of profit that each widget provides, and we came up with some constraints given the information. So what we did is we took these constraints and we graphed them and actually came up with a feasibility region. So now we're going to set up four systems of equations, one for each one of these intersecting points, and find out which one of these points gives us the maximum profit for our optimization equation, which set of values of x and y maximizes this equation right here. All right, so let's go ahead and do that. Let's take a look at this first point right here. So we have this red line and this purple line. So they're described by this equation and this equation. So what we want to do, we know when these two lines intersect, these two equations equal each other. I say equations, they're actually inequalities, but since we're looking for a particular value and not an interval, we're going to set these as equations and we're going to set them equal to each other. So let's go ahead and say 1000 minus x is equal to this one, 1/3 x. And what we can do is we can simply solve for x. So we can add x to both sides. Let's add 3/3x over here. We turn this into a fraction so we can combine these two fractions in the next step. That'll give us, if we put our variable on the left-hand side, we have 4/3x equals 1000. You can go ahead and multiply by the reciprocal of the coefficient of x, which will cancel that coefficient. So we have x is equal to 3/4 times 1000 is 3000 over 4, which is 750. Okay, so we have a value for x. Now we can go ahead and plug it into either equation to solve for our value for y. So we can say y equals, let's go ahead and use this one so we don't have to deal with the fraction. So we have 1000, y equals 1000 minus x, which is 750. And that'll give us 250. So we have our first set of x and y values. So our first set of x and y values is x is 750 and y is 250. All right, so far so good. We have three more systems of equations that we need to set up and solve. So let's go ahead and do so. Let's take a look at this next intersecting point. So we have this blue line and this purple line intersecting. The blue line is given by the equation 800 minus x. And we're going to set that equal to the purple line equation, so 1/3 x again. Not a whole lot to this, we're just using what we know to solve systems of equations. We're going to set this equal to each other, and we're going to add x to both sides. We're going to add 3/3x to this side, just like we did in the previous situation. So we have 4/3 times x equals 800. We can multiply the entire equation by the reciprocal of x, which is 3/4. That'll cancel this coefficient. This is a 4, by the way. That'll give us x on the left-hand side. 3/4 times 800 is 2400 over 4, which is 600. So we have a value for x. We can go ahead and plug that into either the blue or the purple equation. Let's go ahead and use the blue one because, once again, we don't have to deal with fractions. So we have y equals 800 minus 600, which gives us 200. All right, so we have our second set of x and y values. So we have 600 and 200. Now, when we think about it, these are actually different combinations of x and y A and B widgets that we can produce, and we're going to find two more sets that we can plug in one at a time into our optimization equation and see which one gives us the maximum profit. Let's look at this third one, the blue line and the green line. These 2 points are actually going to be fairly simple because y just equals 0. So let's go ahead and set 800 minus x equal to 0. We go ahead and add x to both sides. And this one's just going to give us x equals 800. And when I say it's simple, we're just going to have y equals 100. We don't even have to plug back into any equation because y is always going to equal 100. So let's go ahead and state our third set of points. So we have 800, or a third point, set of values for the point, 800, 0. And when you see this, we actually have the point 800, 0. Now, don't take that for granted. All that means is we actually scaled this fairly accurately. We didn't do so well in the last application, but this is just an approximate graph. So let's not take it for granted, and let's go ahead and plug in for this fourth intersection instead of just saying 1,000 and 0, which it probably is because it's scaled pretty accurately. But let's go ahead and do the work. We have the red line and the green line, so we have the equation 1,000 minus x equals 0. And like I said, we scaled this pretty accurately this time, so this is indeed going to be x is equal to 1,000. And we know for this one, y is going to equal 0. So we have the point 1,000, 0. So 1,000, 0 is our fourth set of x and y values. So now we have 4 sets of x and y values or quantities of widget A and widget B that we can plug in to our optimization equation right here. We plug them in one at a time, and whatever gives us, whatever set of points or set of values gives us the biggest number when we plug it into this equation, that will be our maximum value. All right, so let's go ahead and do this one first. So we have the points 750 and 250. So we have the optimization equation, excuse me, that's a 4. We have the optimization equation 4,000 minus x plus y. So we have minus x is 750 plus y, which is 250. Okay, this is going to be z equals 4,000 minus 750 plus 250. This is going to give us 4,000 minus 500, which gives us a value of 3,500. All right, so these two quantities of widget A and widget B produced gives us a total profit of 3,500. Let's go ahead and check out the other 3 points. So next one we have is 600 and 200. So z equals 4,000 minus 600 for x, and y is 200. Let's go ahead and see what this gives us. So we have 4,000 minus 400, and that gives us 3,600. So we make $100 more profit when we use these two values for our x and y. All right, we have 2 more, so let's go ahead and use 800 and 0. So 4,000 minus 800 for x, and we don't even need to write 0 because, or it's understood, we don't even need to write the second one, or the third one, excuse me. So we have 4,000 minus 800, which is 3,200. That's our third value. And then we have z equals 4,000 minus x, which is 1,000, plus 0. So this will just give us 3,000. Okay, so this company we can see is going to reach a maximum profit of $3,600, and this right here is going to be the best case scenario for producing a certain amount of widget A and widget B. And widget C. We can't forget about widget C, which we'll describe that in a second. So we can say that this company is going to reach a maximum profit. So our max profit for this manufacturing company is going to be $3,600 by producing the following amounts of widgets. So we're going to have x is equal to 600. X we defined as the number of widget A produced. So we're going to produce 600 of widget A. We're going to produce y is 200. Y we defined as widget B, so we're going to produce 200 of widget B. Widget B. And if you recall, we defined widget C as 1,000 minus x plus y. So if we plug those two in, or just say that we have 1,000 total widgets produced, and widget A and B consist of 800 of them, we can say that we're going to produce 200 of widget C, because we produce a total of 1,000 between these 3 widgets. All right, so this is our max profit for this manufacturing company. We produce 600 of widget A, 200 of widget B, and 200 of widget C. The manufacturing company will achieve a maximum profit of $3,600. Now this is probably per day or maybe even per week, but this is the maximum profit given these constraints. Now always remember that this isn't the best case scenario in the world for this manufacturing company, but given these constraints that we have, a few of them were we don't sell more than 200 of widget C, so this is the maximum amount of widget C we can produce, and we sell at least 3 times more of widget A than widget B, so this is actually a pretty accurate set of constraints in a real-world situation. We know we can't produce a negative amount of either widget, so given these constraints, this is the best case scenario for the manufacturer. Look over this a few times. It's actually really, really interesting and really helpful when we're dealing with manufacturing, industrial, and finance and investments as we saw in the previous application. So I will see you in the next video.